Hello, this is Claire, and we're going to look at finding an unknown side length in some triangles using trigonometry. So we're going to use the trig ratios. The first thing you need to do is to draw the triangle that we're going to look at. And as you can see, it's here. The hypotenuse is 3. The unknown side length we've labelled x, and the given degrees is 30 degrees. So firstly, label the sides. So the first one to label is the hypotenuse, and it's opposite the right angle, so call it h. The next one to label is opposite the angle we're given, and it's x, so that's the opposite side length. And the other one, which is unlabelled, which we do not need really in this trig ratio, is the adjacent side length. So it's the third one. That's the easiest way to do it. So looking at your trig ratios, so katoa, so so, ka, toa, you need to decide which trig ratio to use. So you have information about the opposite and the hypotenuse here, and you have the angle. There's no adjacent, and both of those two have the adjacent in them, so it must be sine. So write down the rule. Sine theta equals opposite over hypotenuse. Now substitute in the values. As you can see, theta, or the angle, is 30 degrees. So sine 30 equals the opposite, which is the unknown, and the hypotenuse, which is 3. So after substituting in, you'll need to do some algebra. So if it's divided on one side, that when it crosses over the equals, it will be multiplied on the other. That's using cross multiplication. Or you could say, to remove this 3, which is down here, it's divided, you would need to multiply both sides by 3. So it will be 3 multiplied by sine 30 degrees equals x. And now you have the x by itself. And you'll need to use your calculator. So you turn your calculator on. And let's put in this information. You'll say 3 times sine 30. So 3 times, and choose the sine button. Put in 30, close the brackets, and equals. And the answer is 1.5. So x equals 1.5. Let's have a look at the next one. So this next triangle here is in a different position to this one. We have the angle given as 42 degrees. It's at the top. We have the hypotenuse is 7.2, and we need to find this side length x. So label the side lengths. Opposite the right angle is the hypotenuse, and opposite the angle we've been given is the opposite, and the other side length, which is next to the angle, is the adjacent. So that's very important to label those first, and now to decide on which trig ratio to use. So have your trig ratios written down near you. Okay, so in this case, we don't have anything to do with the opposite. We just need the adjacent and hypotenuse. So it's not sine and it's not tan, and it must be the cosine, the cos ratio. So writing down your rule, cos theta equals the adjacent over the hypotenuse. Substituting in your values, theta, the angle we're given, is 42 degrees. The adjacent side length is x, that's unknown, and the hypotenuse is 7.2. So we're using exactly the same form of algebra here. The unknown is on the top. So when the unknown is on the top, you times. So you will multiply cos 42 by 7.2. 7.2 times cos 42 equals x. Right, so clearing your calculator. 7.2 multiplied by, choose the cosine button, 42, close the bracket, equals. And the answer here, rounded to 1 decimal place, would be 5.35, so you would round up to 5.4. So x equals 5.4, whatever unit that is in question. The last one is a triangle that's on an angle here, and the degrees given is 71 degrees. This side length is 4, and we don't have any information about the hypotenuse here. So labelling the side lengths, opposite the right angle is the hypotenuse, and opposite the angle given is the unknown. So opposite 71 degrees is x, and the other side length, which is adjacent or next to 71, we call the adjacent side length. Soon as you know you do not have any information about the hypotenuse, it will be tangent, the tan ratio, so you can write that one down. So tan theta equals the opposite over the adjacent. So put in the values, tan 71 equals the opposite, which is x, and the adjacent is 4. So the unknown is on the top, x. So when the unknown is on the top, you always times. So 4 crosses the equals and it says 4 times tan 71 degrees equals x. So using your calculator again, 4 multiplied by, use the tan ratio, 71, close the brackets, equals, it's 11.61, and to 1 decimal place, it's just 11.6. So the unknown side length is 11.6. So that's finding unknown side lengths given an angle and one side length in a triangle. And all of those unknown side lengths were on the top of the sine ratio. So next time we'll look at finding the unknown side length when it is on the bottom. Thank you for now. Bye.